talk about this one here, the Rho method. So if you want to rate the quality of a hash function, the basic question is how hard would you have to hunt to find a hash collision? Two different inputs that hash to the same value. So if you start and hash a word, and then you hash the hash, and then you hash the hash, you'll have a series of values like this. So you keep hashing the hash. Someday, eventually, you'll hash it and you'll repeat a number you've already seen. And from that point on, you'll be stuck in this loop forever. Just go around and around seeing the same values. So that's why they call it Rho. Conceptually, it looks like the Greek letter Rho. And so the question is, how far away is this? And the answer is, for any hash function, since the bits are effectively random, they're able to prove pretty easily that the length of this tail is approximately square root of n, where n is the total number of hash values, and the length of this loop is approximately square root of n. So if you have a 128-bit hash function, it'll be 2 to the 64 to get you here, and about 2 to the 64 to go around here. So that's why you can find a collision at about that point. And there's a lot of ways to prove that. The simplest one is the birthday paradox. But anyway, that's the nature of it. And you can see this if you use Python. So if you have a command prompt on, say, a Mac, you can just type Python 3, and then you're in interpreted Python here. So now you can execute commands one by one. So if I take these two, this will import a library that will do hashing, and then calculate an MD5 hash of A. One letter A is the input. I encode it as ASCII, and then I calculate the hash, and then print it out as a hex. So I get this mess, CC175, and you can see it's the same thing I got there. That is the MD5 hash of the one character A. All right. And so now you can check it online. There's online generators to make sure it's right, 0cc. That's what it is. So that's the MD5 hash. Now, as I said, if you did MD5 and you try to do the Rho method, we would have to do 2 to the 64 calculations, and that's far more than we can ever do with this simple system. 2 to the 64 calculations have been done, but that's with supercomputers and giant clusters and piles of money, so we need something easier. So what we're going to do is take something smaller than that. We're going to truncate it. So we're going to take just 2 characters out of the hex. This hex thing is very long. I'm going to just take the 2 characters off the end. And that's 61. I take just the last 2 characters. So now I have a real short hash function with only 256 possible values. So now I can do the Rho function. So I can do this the whole thing. There's my base number starts at A, and then up for 50 times, I'm just going to, the H. H is A. I'm going to encode H and put it in H. So I hash it, and then I store that in the variable, and I hash the hash and hash the hash and so on. So this is the loop. One thing I'll mention about Python, when you have something like a loop that's going to have to repeat 50 times, you put a colon, and then you indent the next lines. That's how you know what's in the loop. So all the indented lines will happen 50 times. So this goes here. Now you press enter twice, and it runs. And there they are, the 50 values that I get. So we want to look for repeats, and one easy thing to do is just change the width of this until you see vertical stripes matching the numbers. There I'm seeing, shouldn't be too hard. I see a 1E, and here's another 1E down there. So I should be able to get them to line up. Yep, there's 1E, 1E, 1E.
Yep.
I'm almost getting it. Almost perfect. There. Okay, now we can see 1E, 1E, 1B. This is where the repeating starts. This is how long the loop is, and this is how long it took to get to the loop. And so it's 256 combinations, so it should be approximately 8 to get to the loop and approximately 8 around the loop. And as you see, it's not exactly that, but it's in that order of magnitude.
So it's essentially mod 8, except it'll mod 8 arithmetic.
Well,
no, repeat sooner than that because it's not a prime.
Well, actually, 16 is what it should be, right? 256, square root of that is 16. No.
I'm just saying, for maximum loop, mod prime. Because it has to go all the way through 1 through P.
Well, yeah, but it's not that way. I mean, it's effectively random. So you do hit a repeat before then. It's not, and so I don't think any benefit would come from having a prime number of possible hash values. It's not that systematic. This estimate is based on saying each hash is effectively a random number.
Yeah, okay.
So anyway, but you see how it worked for this one. So that's the Rho method. And so there's a flag you can get here by starting with a different starting value. Then if you keep the last 3 characters, now you have 16 times more possible values. So again, you can go here, and then you can do a 32-bit hash, which will take longer. But, and you'll have to write a code that detects the match now, because you won't be able to do it manually like this for something long like that. But there's a few variations of the Rho method you can play with. And it's
your flag is the repeat?
Yeah,
right
your flag is the first repeated value. Yeah. So you'll have to make you have to write a program that remembers the values and looks for the first repeat.
Or you could just do that, what you just did.
Well, yeah, but this one's going to be so many with 32 bits that you won't be able to do it manually like this. Anyway, that's the thing. And I think this thing has, one thing I want to mention in case you don't know, is only 15 points are what I expected, and the rest are extra credit. And the extra credit you don't have to turn in by the deadline. You can turn in by the end of the class. You can really turn in any of these projects by the end of the class, but you might lose some points for being late on the required part. So that's why all these are designed, so the first 2 should be pretty easy. And then the rest is extra.
Well, nothing's late until next week, right?
Yeah, that's right. Yeah, yeah. Anyway, so that's the Rho method, which you might want to do. And now I want to talk about something else. I'm going to stop.